Can I start now? Good day, boys and girls. How are you? Hope we are fine and safe. Um, we're going to carry on with our mathematics, and then we'll carry on with our trigonometry class as we started yesterday and then the day before. So we carry on from them. So we looked at trigonometry. We look at the trigonometric ratios. So today we carry on from there. Again, my name is Jafaru Abdullahi Sado. My name is Jafaru Abdullahi Sado, and we carry on with our trigonometry class. All right. So at the end of today's class, we should be able to, first of all, find the sides and angles of triangle using trigonometric ratios. We should be able to find, when we are given a triangle, if you have to find the angle or we have to find the sides, we should be able to find the sides, should be able to find the angle of any given triangle, or when we have two or more triangles put together. Okay. And also at the end of today's lesson, will you be able to solve problems, that are regarding angles of elevation and depression. Be able to solve problems regarding angles of elevation and angles of depression. All right. So let's go slowly. Let's start with example one. Example one says in triangle FUN. In triangle FUN, you can see FUN as sketched. FN is 10. Angle U, FN is 10. Okay. Angle U is 90 degree, or angle U is 90 degree. Okay. And then angle N is 28 degree. Angle N is 28 degrees. Okay. Right. Now the question is calculate the length of FU. Calculate the length of FU rounded to one decimal place. Find the length of FU, round it off to one decimal place. So this is our FU here. So how do we use trig ratios to find FU? So what you're going to consider is going to say, okay, fine. Remember we talked about our three ratios. We talked about the sine theta, about cos theta, the cosine, and the tangent theta, or called the tan theta. And we say sine theta is opposite to hypotenuse. We talk about the SOHCAHTOA. When you say the sine is opposite to hypotenuse, the cos, the cosine, is equal to adjacent to hypotenuse, and then the tan equals to opposite over adjacent. So now we have to find the length of FU here. We have to find this length FU. To find the FU, what do? We're going to say, what is this side here? This side we're looking for, what is it here? This is my included angle. So if this is the included angle, what would this side be? This will be the opposite. Okay. This will be the opposite side. This is the side facing your included angle. Okay, it's the opposite side. Fine. So this opposite, and then the given side, you use what we have to find what you need. We are given 10. With the 10 given, we use it to find what we want. So the side given is hypotenuse. Okay. The side given is the hypotenuse. Okay. Okay, sorry about that. So sorry about that. I'm gonna look at that. The network, I guess it's the network. Okay, right. So we're saying that the side we're looking for is the hypotenuse. Okay, is the hypotenuse, and then this the side given is the hypotenuse 10. All right, and then we have to find the opposite side. We have to find the opposite side FU. So you ask yourself now, which of the trig ratios connects opposite and hypotenuse? Which of the three trig ratios has opposites and hypotenuse? Is it sine, is it cosine, is it tan? So opposite hypotenuse is what? Sine. That is so sine. So we're going to say sine was sine 28 equals to opposite over hypotenuse. So we're going to say sine 28 equals to opposite FU over the hypotenuse 10. So we say was sine 28 equals to FU over 10. Right. So then you cross multiply now. It's a 10 times sine 28. That gives you 10 sine 28. So you punch this in your calculator, and then that will give you 4,7. So in this case, you'll be allowed to use calculator. In this case, be allowed to use calculator because your 28 is not a special angle. Remember, we talked about special angles yesterday. So 28 is not a special angle, so you'll be allowed to use calculator. So you simply punch. Y sign, okay? Y sign, because I'm going to repeat that. We have to find, you see here, we have this side here. We use what we have to get what we need. Again, calculate the length FU. Want to find length of FU. Want to find this length FU. Okay. So we can say, what's the name of this side? What's the name? We must always have two. We must always talk about two sides. So what is this name? This is the opposite. Okay. Is the one opposite the given angle. So this is the opposite. This is the hypotenuse, and this is the adjacent. Okay. That means in this question we're talking about opposites and hypotenuse. That okay? We're dealing with what opposite, which you are looking for, and the hypotenuse, which we're given. So these are the two things we're dealing with. So you now check now which of the three ratios has opposite and hypotenuse, O and H. Which one has O and H? Okay, and to check that is only what so. We talked about so catua. So is what opposite over hypotenuse. So that means it can only be what sine. Is that okay? So that is why we use what sine, because the two sides we have are opposite and the hypotenuse. So that means it's only sine. If it was adjacent and hypotenuse, if it was adjacent and hypotenuse, then you could have used what cos. Then you could have said what cos for 28. If it was opposite and adjacent, then you could have said what tan, because tan is what is TOA. TOA has tan has what opposite and adjacent. But here now we have what opposite and hypotenuse. So that means it's what sine. So that's why I say what sine 28. Sine 28 equals to opposite FU over hypotenuse 10. So sine 28 equals to opposite FU over hypotenuse 10. Hope that is clear. Hope you get that. Okay. Now from there we cross multiply to find our FU. So cross multiply over 1 times FU gives you FU. So F equals to 1 times sine 28, 10 sine 28. So punch this in your calculator, get 4,7. Okay, in one decimal place. Don't forget to always follow the instruction. If it's one decimal place, you must do that. If you don't approximate one decimal place, then you're going to lose mark for that. You're going to lose mark for not rounding off. So to one decimal place, you're going to get FU as this. Hope that is clear. Hope you understand that. All right. So you can go to the next example now. All right. Example 2. Consider the triangle sketched alongside. Consider this triangle sketched alongside. Right. Calculate the length of ON, correct to one decimal place. Calculate the length of ON. You see there. Calculate the length of ON, correct to one decimal place. So we're going to check now. We want to find ON. Okay. So which two sides are we considering here? Which two sides are we talking about here? Which two sides? So this side, this is our angle here. Because it's our angle, then this is our opposite. Okay, then this is our opposite. Okay, and then this here will be our hypotenuse, because it's the side facing your 90 degrees. So this is our opposite, this is our hypotenuse, and this will be our adjacent. Okay, opposite, hypotenuse, adjacent. Right. So again, the question is to calculate what ON. You must find side ON. All right. So we're going to say now, which two sides am I talking about? I'm talking about what? Adjacent and what? Opposite. I'm talking about what? Adjacent and opposite, because I will always use what I'm giving, what I have, to get what I want. I want this, I have this. That means I'm dealing with these two sides. All right. I'm dealing with these two sides. Okay. So adjacent and opposite. So which trig ratio has adjacent and opposite? Adjacent, opposite, and adjacent is tan, toa, so katoa. So O and A is for tan. So that means you must say what tan what. That means you must choose what tan. We say what tan of the angle 53. So tan 57 rather, tan 57 is equals to opposite, which is 12,1 over adjacent ON that we are looking for. Okay. So tan 57, because to opposite, okay, all right, okay. I'm gonna take it slower now. Okay, I'm gonna take it slower. All right, thank you, Nolutando. Thanks, Nolutando. All right. So we're saying again, consider the triangle sketch alongside. Okay, consider the triangle sketch alongside. Okay, calculate the length of ON. Correct one decimal place. Calculate the length of ON. We should find this length ON. Okay, find this length ON. Okay, right. So how do we go about this? So to go about this, we're gonna use our given side. Okay, we're gonna use our given side to find what we want. Okay, we're going to use our given side to get the side that we want. We want to find sine ON. Okay, we want to find the sine ON. All right, so we're going to use the 12.1 that we are given to find our ON. So how do we go about that? The side we're looking for is the adjacent. Is the adjacent, because this here is opposite. Okay, this is opposite. This is adjacent and this is hypotenuse. Right. So we are talking about what? Opposite and adjacent. So which of the three ratios has opposite and adjacent? So that is what? Tan. That is tan. Okay, that is tan. So when we say tan of the angle 57 equals to opposite over adjacent. So, and then our adjacent is the ON. So it will be opposite to 12.1 over ON, the adjacent equal to tan 57. Then what do we do here? We cross multiply. We cross multiply tan 57 times ON will give you ON tan 57. Then over 1. 1 times 12.1 will give you 12.1. So 12.1 equals to ON tan 57. Okay. Now, to find our ON, then we divide both sides by tan 57. We divide both sides by tan 57. So ON equals to 12.1 divided by tan 57. You understand? So then you now punch this in your calculator, and then you get what? 7.9. If you punch this in your calculator, you get 7.9. Okay. Okay. All right. Okay. Cyan. I'm going to repeat that. I'm going to repeat that. Okay. Right. So Cyan is asking, when do we use sine, when do we use cos, when do we use tan? Okay. So sine, cosine, and tan, they are the three ratios. Okay. We call them three ratios. Okay. Right. So now we use sine when we have opposite side and hypotenuse side. So we're going to use sine if we got opposite and hypotenuse. You must check the side you have on the triangle. On the triangle, there are three sides. Okay, there are three sides on the triangle. So you check now which two sides. I mean, which when you look at now, the one you're looking for, there must be one you're giving, and the other one you're looking for. Okay. Okay. All right. White tan. So white tan. The white tan. Tan being because we have got opposite. We got opposite. We're giving opposite. Okay. And then here is what? Adjacent. And this side is hypotenuse. The first thing to do is to first of all understand which two sides are you giving? Which two sides are you dealing with? Okay, to decide which to use, to decide which one you're going to use, maybe it's tan, maybe it's sine, or it's cos, you need to decide which two sides are you dealing with. Okay, which two sides are you dealing with? Meaning, it must be that you have one side given, and you would have to find another side. So, what is the name of these two sides? What is their name? So, if you can get the name of these two sides, then you can decide which one to use. In this case, we have to find what? Adjacent, and we're giving what? Opposite. Okay, we have to find what? Adjacent, and we are giving opposite. So now, without doubt, we can see that it is tan we're going to use, because tan has what? Is the only one that has what? Opposite and adjacent. Because this one is hypotenuse. This here is hypotenuse. It is side facing your 90 degrees. So this is hypotenuse, no doubt. This is your opposite, this is adjacent. So again, how do we know if you're going to use sine or cosine or use tan? So we're going to check now. I'm dealing with. The two sides must be that we're giving one of now. What's the name of these two? What is the name? Okay, what is their name? So the name of this one is adjacent. The name is opposite. So they're going to be what tan. They're going to say what tan 50.7 equals to opposite 12.1 over adjacent ON. Name call it what ON. We say tan 57 equals to opposite 12.1 and adjacent ON. Okay, and then you can cross multiply. ON times tan 57 gets you ON times 7. Then this tan 57 over 1. So 1 times 12.1 will give you 12 tan 57. Okay, so we're going to have what ON equals to 12.1 divided by tan 57. That's fine. And then you can just punch this in your calculator and get this in one decimal place. Do we understand? We understand that. And then alternatively, if you don't want to do this, if you don't want to do this method, because remember in the triangle there are 3 angles in the triangle, and the 3 angles must add up to 180. Okay, so there is 90, there is what 57. So I know that these 3 angles must add up to 180. So I can find my angle C. So what will my angle C be for these 3 angles to add up to 180? We'll say 90 plus 90 plus 57. 90 plus 57 plus C must give you 180. Isn't it? So our C then will be what? 90 plus 57 is 147. So to find your C will be what? 180 minus 147, and that will be what? 33. So that means our C angle C will be what? 33. So you can use angle C to find what? ON as well. So if you don't want to use 57, you can choose to use what? Angle C. Now we are trying to see now, if you are going to use angle C now, how are we going to do it? So this one is one method. So if you use any method, you must always get the same answer. So now we are trying to use angle C now. Try to get angle C. We say angle C must be 33 because these 3 angles must add up to 180. Okay. So angle C is 33. I'm sure you get that. Okay. So if this is 33, now because this is angle 33 we are looking at, then this will be our opposite. Our ON will be our opposite. Why? We are considering this as our angle. We are no more looking at 57. When we were looking at 57, this was our opposite. But now we are looking from the C angle now. From the C angle, this will be our opposite. And then this will be our adjacent. This always see hypotenuse. Hypotenuse doesn't change based on the angle where the angle is. When the angle is there, your opposite will be here. If the angle is there, then your opposite will be here. Okay. So now this our C is what? 33 degrees. Okay. So because there's 33 degrees, there'll be our opposite. Okay. So now that means we have opposite and we have what? Adjacent. We have opposite. We are looking for opposites. Remember, we are looking for ON. So that means we are looking for opposites. Give me what? adjacent. Okay, we are looking for opposites giving adjacent when we are considering 33 degrees here. So in that case now, so which trigonometry should add what opposite and adjacent? Then is what will be tan. Okay, then it will be what tan opposite adjacent is 10. And you can see what tan 33 degrees equals to opposite ON over adjacent 12,1. Okay, so therefore it's what tan 33 degrees equals to opposite over adjacent. 33 degrees, 33 degrees is what opposite over adjacent, because these are two sides that we are talking about, we are dealing with, the one we're looking for and the one we have. So we are looking for opposite, we are giving what adjacent. So what connects opposite and adjacent is tan. You see what tan off of 33. So 33 equals to opposite ON over adjacent 12,1. And then we do the same thing, we cross multiply. So cross multiplying, this over 1, ON times 1 gives you ON. Then 12 tan 33 gives you 12,1 tan 33. Then you can punch this in your calculator, 12,1 tan 33. Punch it as it is. Then we come to this. Okay, in one decimal place. I hope you understand that. I hope we do understand that. So now go to the next one. Let's stand that example, maybe you understand better. All right. Right. Okay. Now, example 3 now. Calculate the size of angle. Correct one decimal place in each case. So there are two questions here. This question A, this question B. Okay. Now find angle theta. You must find angle theta here, and then here you must also find angle theta. All right. So let's start with A now. We need to find angle theta. Fine. Sharp. Now, what are the two things we are giving? What are the things we are giving? We're giving what 10 and what 16. We're giving 10. So this 10, what's ordering of this side is adjacent. This is what opposite, and this is your hypotenuse. Obviously, hypotenuse is the one facing your 90 degree. So this is your opposite. This is your adjacent. This is your hypotenuse. So basically, we are giving what adjacent and hypotenuse. So we're going to work with two now. We always work with two. Okay. Right. So now, which of the two ratios has what adjacent and hypotenuse? Which one has what adjacent and hypotenuse? So adjacent A, hypotenuse H. So which one has what opposite adjacent hypotenuse what cos? Remember, so car is what adjacent over hypotenuse CAH. So cos the one with what adjacent and hypotenuse. We're going to see what cos theta. We're going to see what cos theta equals to adjacent 10 over hypotenuse 16. And we're going to divide that, and then we find the cos inverse. We find our theta by finding the inverse of the cos. So let's see how that looks like now. So let's see on the next slide what we have there. Okay, so now we use cos theta because the two sides we are talking about there is adjacent and hypotenuse. It's adjacent and hypotenuse. Right. Again, why did we use cos? We are using cos because the two sides we are talking about that we are dealing with are adjacent and hypotenuse. So which ratio has adjacent and hypotenuse is cos. Then we're going to say cos theta equals to adjacent over hypotenuse. So cos theta equals to adjacent over hypotenuse. Right. So adjacent is 10, hypotenuse is 16. They're going to divide this amount. So divide 10 divided by 16 will give you this amount. Okay, we're going to get this amount. So cos theta equals to 0,625. Therefore, to find your theta, remember you have to find theta. When you find the cos inverse, we did explain this in yesterday's class. When the cos inverse of what? You press shift cos 0,625. Shift on your top left corner of your calculator. Shift cos 0,625. Then when you come to this, corrected to one decimal place. Okay, so that's your theta then. We talk about what question 1, question A. All right. Now let's see question B now. So by question B, you have to find theta as well. have to find theta sharp. So what are the things we got? What are the things we have? We got what? Remember, this is your hypotenuse. The side facing your 90. So this here is your opposite. Is the side facing your angle. This is the opposite, and this is your adjacent. This hypotenuse, opposite, adjacent. Okay. So because of find theta, so and we have these two sides. So which trig ratio has opposites and adjacent? Which trig ratio has opposites and adjacent? So that's only what TOA. Opposite adjacent is what TOA. Tan. Right. So capital tan. Right. So we can say what tan theta. We say what tan theta equals to opposite over adjacent. So cos tan theta will be opposite, which is 11,2 divided by 13 centimeters. So we're going to say tan theta equals to that. So let's see there. So we'll say tan theta equals to opposite over adjacent. So tan theta equals to 11,2 over 13. All right. And then what do? You simplify this. Punch this, simplify this. It's going to give you this. And again, don't round off. Because if you round off, it's going to lower, it's going to shorten your answer, it will make your answer not to be accurate. Once you have solved so long answer like this one, I give you exact, it terminates. It don't terminate, it didn't give you so long. You can also terminate, but it's usually on the curve. It's carried on for it's a long value. It's saying don't approximate it. Your approximation must be at the end of your calculation. Again, in the course of calculation, do not approximate. Only approximate at the final end of your calculation. So even though it's a long answer, it's allowed. It's allowed to write only 0,682. You can just write what you can just write. You can write down the short answer. If you don't have time, instead of wasting time to write all this long answer, it's allowed to write the short answer. Okay, the rounded answer. But if you're going to use it in the next calculation, then you must use your calculator as a work of previous answer. It has previous answer. It's on the button there at the bottom right corner that says previous answer. So we're going to just press that previous answer and then say tan inverse of previous answer. You understand? So that means in your calculation, you are using the full value, but on your paper, you are writing the short value. So that is allowed. So instead of wasting time to write all these lots, so you can choose to write the short form of it, fine. But to do your next calculation, you have to use the full value, which you can get in your calculator by using what? Press previous answer. It's previous. So punch previous answer. The answer you can say tan inverse previous answer. Shift tan previous answer. Come like this in one decimal place. So at the final answer, you can round it up to one decimal place. You understand? So in our calculation, in all calculations, we don't approximate. In the course of our calculation, we approximate at the end of the answer. Hope you understand. I'm sure you understand this. Okay. Now let's see another one then. Right. So on the next slide, so we got this other one again. Using information provided on the given diagram, calculate the length of BC. Calculate the length of BC. So how do you find length BC? So this is length BC. So how many triangles we got here? 1, 2, 3. We got 3 triangles here. You have to find length BC. You have to find this length. Okay. Right. So now, again, this same, you use what you have to get what you need. Use what you have to get what you need. Right. So now you start from the triangle with more information. So there are 3 triangles here. Which one has more information? Which of the 3 triangles has more information? So obviously is the first one. Is the triangle EAD. Because at least we have what 70 millimeters here. This one doesn't have the rest 2 doesn't have anything. So you start off with the one with the most information. Right. That one with the most information. Okay, fine. Right. So now, so with this 70 you are giving, then we have to find BC here. BC is far from what? This. So you have to now walk right from here down up to this other triangle. You start off from where you have more information and walk down until you get to where you where you are asked to find. Right. So we'll start off from here now. So this, in this triangle EAD, which side can we find now? We need to move from here, we need to move here. So you can see that AD connects the two triangles. AD connects the two triangles. So we can find length what? AD. We can use what? 70 millimeters to find length AD. So once we get length AD, then we can now use what? AD, whatever we get by AD, we can use the AD to find what? AC. Once we have AD, with AD, we can use the answer to find what? AC. All right. So, and once we have AC, we can use the answer for AC to find your what? BC. You understand? So just go in steps in that order. So again, you start from the triangle with more information, which is this first one. Okay. So here is so what side is this here? What is the name of this side? This side here, this is the triangle AEAD. So this is our angle here. Because it's our angle, our ED is our opposite. ED is our opposite. Okay. And this is our this will be what? This will be our hypotenuse. It will be our hypotenuse. Why is it our hypotenuse? If you see here, there is 90 degree, right? This here is 90 degree. Remember, hypotenuse always face the angle 90. The hypotenuse is that side that faces the angle 90. So if this is 90, that means the balance of this here, this other balance of this angle will also be 90 degree, because we must have what? This is straight angle, which must be 180. So if this is 90, that means our 90 is also here. So by D here is also what's 90 degree here. Okay, it's 90 degree by that point, right? So because that's 90 degree, that tells you that this is hypotenuse. So there is opposite, this hypotenuse, then is what? Adjacent. All right. Again, opposite, hypotenuse, adjacent. So now we say we need to use what? Our 70 to find what? Adjacent, to find this side. Okay. Use the 70 to find the adjacent. So what side are we talking about here? We're talking about adjacent and hypotenuse. Adjacent AD and hypotenuse 70. So which one has adjacent and hypotenuse is what? Cos. So cos. So adjacent hypotenuse is cos. So we say what? Cos 40. Cos 40 degree equals to adjacent AD over hypotenuse. So like that, you get your what? AD. Okay. So once you get your AD, the way to AD, you can find your what? AC now. So now you have your AD. So you need to use AD to find AC. So by AD, what is the side AD? The side AD is your what? Remember, this is your 90 degree. If this is 90 degree, this side will be your hypotenuse. The side facing your 90 degree. So AC is your hypotenuse, and then AD will be your adjacent, because this side is your opposite. Opposite is that side that is facing your angle. So this is the opposite. AC is your hypotenuse. AD is your adjacent. All right. Now, so which trig ratio has what? Has adjacent and hypotenuse. Remember, here we said AC is our hypotenuse, our AD is our adjacent. So which one has adjacent and hypotenuse is still what? Cos. Adjacent, hypotenuse is still cos. They're going to do what? Cos 36 equals to adjacent 14 over AC. And so what? Cos 36 equals to 14 over AC. So like that, you can replace our AC. You do your cross multiplying and you find your AC. Okay. So once you get your AC now, right? So with your AC, you can use your AC to find your your BC, which you are actually looking for. So by your BC now we have our AC sharp. So our AC, now looking at this triangle now, this side is called the hypotenuse because it's the side facing this angle 90 here. So if the hypotenuse, considering this last triangle CAB, so this is our hypotenuse, and this is our opposite because it's side facing our angle 20, and these are our adjacent. All right. So now because we want what BC, BC is what opposite, and this one is what hypotenuse. Which one has opposite O, hypotenuse H? Which ratio are you going to use there? Opposite and hypotenuse. So that's what the sign, opposite and hypotenuse sine. So what sine 20 degrees equals to opposite BC over hypotenuse, whatever our AC is. And we calculate that, we find our BC. Okay, so like that, we do the kind of question. So without wasting much time, we go to elevation and depression now. So let's go to elevation and depression so that we'll be able to talk about that. Angle of elevation and depression. So what do you mean angle of elevation and what do you mean angle of depression? So like here now, if you're standing there, for example, if you're standing by N, you're standing at this point N, and then you have like a tall mango tree right in front of you. You are standing at point N, and then by you have a tall mango tree. Okay, to see the mango tree, if you look straight this way, you will never see a mango. Okay, you standing at N, a mango tree is UF standing in front of you. Okay, it's standing straight in front of you. This is a mango tree standing in front of you. So for you to see the mango on the tree, you need to raise your line, your plane of sight, your sight of seeing. You need to raise your head at an angle. You need to what? You need to elevate. You need to raise your head at an angle for you to see the mango on the tree. So the angle between your straight point of the straight plane and the angle. I mean the side you must look to see the mango is your angle of elevation. Okay, so we say this theta is our angle of elevation. So that angle you need to move your head through. For you to see the mango is your angle of elevation. Okay, so see our theta is your angle of elevation. Okay, so theta is an angle of elevation of what? F from N. So for you to see F from N, so theta is the angle of elevation. You need to raise your head. You need to raise your head up. Otherwise, you can never see what F. We can never see the mango on the tree. Okay, so you need to elevate. You need to go through this angle for you to see. So this angle is called elevation. Okay, and then for depression, say you're on top of the tree now. Say you're on top of the tree, and then you need to see your friend at the bottom, somewhere far on the ground. You are at the top of the tree by F. And now you need to see your friend at the bottom on the ground. Right. So if you look straight this way, you will never be able to see your friend. But to see your friend on the floor, on the ground, you need to depress, you need to put your head down, to look downwards. So the angle between this horizontal plane and this side here, this angle you're looking at, we call it the angle of depression. We call it the angle of depression. Okay, listen, that's the angle of elevation and depression. So it's angle of depression, right? So now you must also understand now that this angle here beta and this angle here they are equal. The angle here and the angle here they are equal. Remember they are what? Alternate angle, because we say this plane must be parallel to what? Parallel to your NU. So NU is parallel to this plane. So this when these two lines are parallel, we say these two angles are alternate. And remember, alternate angles are equal. Isn't it? Alternate angles are equal. So note that in case you are doing your calculations, so note that this angle is always equal to this. Okay, let's see an example to illustrate that. Okay, now look at this now. The angle of depression of a boat, the angle of depression of a boat on the ocean from the top of a cliff is 55 degrees. Okay, the angle of depression of a boat on the sea, on the ocean, there's a boat here on the ocean. Okay, Right. So now the angle of depression, the angle of depression of the boat, yeah, of the boat on the ocean from where? From the top of the cliff. This is the cliff here. From the top, the angle of depression. So you're gonna draw your horizontal line like this, and then you're gonna draw a line that goes to the boat. So you put your angle here, and that angle is the angle of depression. So you say the angle is 55 degrees, so you put your 55 degree here. You understand now? We'll put here 55 degrees. Okay, the angle of depression of the boat or the ocean from the top of the cliff is 55 degrees, right? The boat is 70 meters from the foot of the cliff. The boat is 70 meters from the foot of the cliff. There's the cliff, this is the foot of the cliff, there's the boat. So it's 70 meters from the foot of the cliff. Right. Now, question. What is the angle of elevation of the top of the cliff from the boat? What is the angle of elevation on the top of the cliff from the boat? Now, from this boat, now, what is the angle of elevation of the top of this cliff? From here, what's the angle of elevation of this top? What will be the angle? What will be the angle of elevation of this top now from the boat? The angle of depression from the top to the boat is 55. That angle of depression, the angle between this straight line and this line is 55 degrees. Now the question Anna is what's the angle of elevation of the top of it from the boat? So that would be what? Same 55 degrees. Remember I'm saying what this angle is same as this. So that's simply what 55 degrees. So 55 degrees the angle of elevation. Meaning for you to see this top, you must go what? 55 degrees. So because these two lines are what? Alternate and they are equal. So basically answer is what 55 degrees. Okay. So what is the angle of elevation of the top of the cliff from the boat is 55 degrees. Okay. Right. Finally, calculate the height of the cliff. Calculate the height of the cliff. So find the height of the cliff is easy. So because say 55 degrees sharp, so we need to find this height. Now this 55 degree, this is 70 degree, 70 meters. We need to find this height. So with this 70 we have, we can find this one. So what is the name of this side? Looking at the angle from here, this is the 55 degree, don't follow. There's the 55 degree, right? So this is your what? So because this is your 55 degree, will be your opposite. Your opposite, right? Okay, that'll be your opposite, and this is your adjacent. This is your what? Hypotenuse. So what trig ratio has what opposite and adjacent? That's what tan. Opposite, adjacent is tan. Then we say what? Tan 55 degrees. Tan 55 degrees equals to opposite over adjacent. So 55 degrees was h over 70. And from there you can solve for your h. Okay. So let's see how that looks like quickly. Right. So the angle of elevation of the top of the cliff from the boat is 55 degrees. Okay. All right. So we can calculate the height of the cliff as follows. So these are h, these are 55 degrees, these are 55 degrees as well. So these are our opposite, these are adjacent, these are our hypotenuse. So our tan 55 degrees opposite, 55 over adjacent, 70, then we cross multiply. So h equals to 70 times tan 55, and that will give you 100 meters. Okay, so we're going to end the class for today. This is one. This is the takeaway question for you to ponder upon to see how much you can take a picture of it and then a snap picture of it and then try to do it for more understanding. Okay, thank you for attending to this lesson and enjoy the rest of your day.